Can you tell I'm used to a mouse? Okay. The equinox is September 22nd at 6:04 our time. It's on the 23rd universal time. Interesting. And this month I've got a little bit of stuff to say about Saturn. It's retrograde at the moment. And stellarium is good for a close-up of that. Jupiter is retrograde slightly more because it's closer to us. Mars is still going around the way it's supposed to because it's ahead of us and we're catching up to it though. But it's going to do a nice little prograde loop. And once Charles showed me how to do the calculations in stellarium, I've been playing with that for ages. It's neat. And you can see the nice little loop that Mars is going to make in the sky, just north of Orion. It's really going to be a cool opposition for Mars this year. That comes in December. But it's going to be occulted by the full moon, which is one of the things you don't see every month. Now, the one thing I didn't put in, I mentioned it in the article in the Coast Reporter. If you've got people you want to show off to, the weather is still good, and you can show people all kinds of passes of the International Space Station. It's been early morning up until about now, and then it flips to evening passes about the 12th. So off we go. So that's when the sun is directly over the equator. And okay, but where? Now, if it's 1804 here, obviously it's not directly over us. We're not on the equator either. But if you do the math, Greenwich has moved 64 minutes past midnight. So the 180-degree meridian has moved the same past noon. So it should be 165 degrees east on the equator, which takes you to the almost lovely little island of Nauru. I think that's how you pronounce it. I don't know. So that's really the only thing on the map in that part of the Pacific. It has rather a checkered history, interestingly. It doesn't look like your average tropical coral atoll because it was covered in phosphate rock, which they strip mined to the tune of 90+% of the island. So all that non-green stuff is basically rock. And interestingly, later on in its history, when the island, it's a country actually, they went broke because the phosphate rock ran out. So now their per capita annual income is under $1,000 a year. They sold or took a lot of money from Australia, who built certain little structures in there. You can see the gray areas in the middle. Those are asylum seekers camps. So if you show up on the borders of Australia in a boat from Indonesia or places in that vicinity, and they catch you, you're going here. And at some point in time, possibly, you get to come off. Where you go is not my concern, but it's, I wouldn't, there's 10,000 people there who are no Naurus. And I apologize for my ignorance. However, the phosphate rock got mined. Now it's all gone and everybody's broke. And according to one Brit journalist, 71% of the residents are obese. And only American Samoa is worse. Anyway, Australia, which used to sort of run the place, threw a bunch of cash at them in 2001. And this is where they park all their illegal migrants who come to Australia.
Question?
Yeah.
You know the geology of that island, like what's the great deep phosphate in the middle of the Pacific Ocean?
I didn't have time to figure that out. I thought, what? It says phosphate rock. Now I was thinking, okay, they've done that in various islands where they just scoop all the bird poo, 100,000 years of it. And it's terrific fertilizer. I don't know what they use phosphate rock for, but I'm going to have to find out. Well, okay, if that's the use for it. At any rate, that's the history in a nutshell. Okay. Yes. Saturn is now past opposition. It's outboard of us, we're inboard, and we move faster. So for this period from September 9th to October 14th, that's what Saturn does in the sky. And I don't know if it's completely clear. I can see it, but where the planet label is, Saturn, on the left end of that yellow line, those are daily positions. And you can see them fairly far apart, and then it moves over to the right and they get squished closer together. So it's actually in retrograde motion relative to the stars. It's moving from left to right each night, but it's slowing down because we've come around between it and the sun. That was last month. And now we're going past it. So its retrograde motion is going to slow down and stop. When I didn't look, but it actually does move. And these stars, Deneb, Algety, and Nashira, are visible enough in binoculars that you can actually see it move. I tried seeing it last month and I didn't get enough chances to see it actually move. However, anyone who's into astrophotography, and I'm thinking of you, Mr. Mitchell, would probably be able to do that in no time flat. So, and in 10 minutes, this is what it will look like. Now with my 8-inch scope, I've pulled Tighten up lots. I don't know that I've ever gotten any of the smaller moons, but that's what it would look like at about 150 power through a decent scope. So that's what Saturn is doing this month. And all three of the planets that are naked eye visible, outer planets, Mars, Jupiter, Saturn, they're all moving, which I did a presentation to a bunch of kids one time up in Whitehorse. And I asked them to get a pad of paper and have their dad drill a couple of holes an inch apart at the bottom, because Mars was doing a big loop. And then you write the name on you write the date, one per sheet of paper, this day, the next day, the next day, the next day. And if you drilled the holes, those were the two reference stars. And each day when you flip to that date and you look up at the sky and you say, okay, it's about here. And you mark that on the paper. And when you're done, you got a movie. You flip it. And Mars will do this through the sky. It doesn't quite do it this year, but anyway, there is Saturn, and Titan is, I've never tried to pick it out with high power binoculars. I think you need a scope to get the separation, but I remain optimistic. Next is Jupiter. And I apologize for not getting these to exactly the same scale. Jupiter is in the east, of course, so the line is moving up, but it's in retrograde motion too. I forget what day, I think it's 26th of September, it's in actual opposition. So our motion will be fast, its motion retrograde will be the fastest then. And you can't quite, well, I can sort of see it. It doesn't look to be slowing down, the separation between the dots. It's impossible to tell there. I'm looking straight at the computer and I can't really see it. And in 8 minutes, this is what it looks like. Yeah. Okay, so that's Jupiter. What's left? Mars. Now what I did was, and this is the cool thing. So what you can see, now this date is for October 14th. So the position of each of the planets is, you can see the motion, the ephemeris of Saturn on the right, Jupiter in the middle right, and Mars on the left. Mars is moving from right to left through the sky. Jupiter and Saturn are moving from left to right. They're in retrograde motion. And on the 14th of October, Mars and the moon will be very close to each other. So this gives you an idea. You can tell the closer it is to us. Well, Mars moves more quickly than Jupiter and Saturn, but the closer they are to us, the greater the angular motion through the sky. So it's quite, and the other thing is if you sit here with Stellarium and you run it at more than regular speed, you can tune it up to where you'll actually see the motion. Next. And that's what Mars looks like at midnight with a scope that's a lot better than mine, because I've never seen that kind of detail. It's always sort of a brick-colored blob. At any rate, this is from tonight to, I think it was April 10th next year. And that's the motion that Mars is going to be doing. So it moves left, then it stops, moves up to the right, stops, and goes scooting off to the left again. And you've got Orion underneath for scale.
You know when the next Mars opposition is supposed to be?
It's, I think, December 7th this year. I think I have a picture of that too. Now, next one. There's a couple of neat nights if you have clear skies. You can see Jupiter beautifully because it's very close to opposition, so it's as close as we get to it. You don't often find all the moons on one side of the planet. And what's really neat is in this one, they're in order. from Jupiter outwards, it's Io, Europa, Ganymede, and Callisto. You see that every now and then, but not every day. And then later, now Io and Europa are reversed, but Ganymede and Callisto are in order. And that's October 13th. And they're all on the right-hand side of the planet. Now these, from what I know, the stellarium data on the moons and the actual rotation of the planets and stuff is very well known and very accurate. It's much less so if you're trying to look for the space station. You can see it on stellarium. They have that data in there. But it can get out fairly quickly because the station drops and then they boost it, then it drops, then they boost it, and so on. This is what it'll look like on the 27th. I've zoomed in here, and the moon at about 7 o'clock on the limb of Jupiter is Ganymede, and right above it you can see the great red spot. And I'm told these things, you know, are really well timed. They've got it accurate as hell. So this would be a neat time to drag out the scope and take a look at Jupiter. Now, I believe opposition of Mars comes, I think it's December 7th. Yep. And that's the moon. It's going to occult Mars. Now this one, okay, they're actually showing on Mars the North Polar Cap, which is cool. And the little 4 marks around Mars, those aren't real. That's just it's showing it's highlighted, okay? And the moon takes about an hour and a half to pass in front of Mars. Now this will be covered later on, but you know what you're in for? December 7th, a date that will live in infamy. And that's it.